Welcome to Math 1201 video number 7. This video is going to deal with one of the ways to calculate a determinant for a square matrix. We will take a look at the weave method for 2x2 and 3x3 square matrices. So I'm going to start off with the definition of a determinant. Now we talked a little bit about matrices and invertibility, and the idea of the determinant is to try to figure out quickly whether or not a matrix is invertible. So the determinant is a special value associated with our square matrix A, and we're going to denote it as DETA. How does the determinant tell us some information about the invertibility? Well, here it is. You know it's important because it's got some red chalk and blue chalk associated with it. If your determinant is equal to 0, A is not invertible. If your determinant is not equal to 0, then A is invertible. We're also going to use this theorem here, which we will prove in a couple chapters from now, and that theorem states that if your reduced row echelon form of A is an identity matrix, then A is invertible. So what I want to do for you next is give you a little bit of motivation as to where the 2x2 determinant comes from. So we're going to take this 2x2 matrix A, and we're going to get it to reduced row echelon form. So the first step we would have to do is create our leading one in the 1, 1 spot, and we can do that by dividing row 1 by A. When we do this operation, here's what we get. We got 1 B over A, and there is no change to row 2. Our second step, we would take row 2 and subtract C, row 1s. And when we do that operation, we're going to get something that looks like this. Okay, B minus BC over A. So what we're going to do next is I've pulled out that 2, 2 entry, and we're going to force this entry to be equal to 0. Because if we get a 0 in that 2, 2 entry, then we don't have reduced row echelon form that's equal to an identity matrix. So let's take a look at when this 2, 2 entry is equal to 0. If we multiply each of these terms by A, we get this expression, AD minus BC is equal to 0. So if this is satisfied, then we don't have an inverse for our 2x2 matrix. Usually this is called the determinant of our 2x2 matrix. And hopefully you remember seeing this before when I gave you that shortcut for the 2x2 inverse. So there it is. There's your 2x2 formula for the determinant. It's AD minus BC. And if this number is equal to 0, A is not invertible. So next I want to take a look at two examples. So here's A, here's B. We're going to find the 2x2 determinants for each of these matrices. So let's start off with A. What is the determinant of A? How I like to think about it is I like to think about it as directed arrows. So I'm going to go from the top left down to the bottom right, and I'm going to multiply those entries together. So in this case I'm going to get 1 times 2 for 2. And then I'm going to start in the top right and go down to the bottom left. I'm going to subtract the product that I get from these entries. So in this case, when I multiply these together, I'm going to get 0. So we're going to subtract off 0. The determinant for A is equal to 2. So is A invertible or is A not invertible? In this case, A is going to be invertible because this determinant is not equal to 0. Now let's quickly do the same thing for matrix B. So let's find the determinant of B. We're going to multiply those 2 entries that are on the main diagonal, and that's going to give us 2. And we're going to subtract the multiplication of these other 2 entries, which is also equal to 2. When we do this subtraction and simplify, we get that the determinant of B is equal to 0. And this tells us that B is not going to have an inverse. If A is a 3 by 3 matrix, things get a little bit different. So that formula that we obtain after doing our elementary row operations is a bit longer than the case for the 2 by 2 matrices. So in this case we get, this outrageous expression with 3 additions and 3 subtractions. And I'd rather you learn a method to compute this determinant rather than memorize that formula. So the real question is, how do we obtain this formula from our 3 by 3 matrix? So your first step is to adjoin the first 2 columns on the right-hand side of your matrix A. So after you have adjoined those first 2 columns over on the right-hand side like so, you're going to start in the upper left corner of your matrix and draw 3 arrows down and to the right. Those 3 arrows are going to look something like this. So the first arrow we get is A, E, I, the second one is B, F, G, and the third one is C, D, H. That's where our first 3 terms come from. And those first 3 products get added together. After you finished calculating those first 3 terms, the next step is to draw 3 arrows down and to the left, starting in the upper right-hand spot. So we're going to get B, D, I, A, F, H, and C, E, G when we do this. Those products are going to be subtracted from your original 3 products that you added together. So let's take a look at an example of this 3 by 3 weave method is what we call it. So your first step, what you want to do is you want to take these first 2 columns of your matrix and adjoin them over here on the right-hand side. So that's always my first step. After you've done this, then you're going to create those first 3 arrows going down and to the right. So those first 3 arrows are here, here, and here. So this first multiplication we will get is 1 by 2 by 1. That's 2. Second one is 0. And third one is negative 21. What you want to do after you've done this summation is you want to take your arrows going down and to the left. Those 3 are here. So here's the first one. Where is my second one? There's the second one. And here is the third one. We're going to be subtracting these products. So the first one we get is 0. Second one we get is minus 14. And the third one we get is negative 5. So when you do add all of these terms together, we end up with that the determinant of A is equal to 0. So this special value here tells us that the matrix A is not going to be invertible.